Welcome to the Kontinuum lab and welcome to another Control Freak build video. This video tells the story of how I added a double analog slider made out of MiniDV tape to the fantastic virus pad instrument. In the previous video I did manage to make one of these sliders here that was kind of not very sensitive and honestly barely functional. But in this video I cracked the code. I worked out all the kinks and solved all the problems and I got it right. So this is the definitive build video and tutorial if you want to learn how to make awesome analog sliders out of MiniDV tapes just like these ones. This is kind of a long one, so get a beverage, get comfortable, let's get started. So to explain the problems that I found and the solutions to them, let me just bring out first of all the final sensor that I ended up with last time, which still has all of the problems, and then the new sensor, which is what I then went on to make, which solves all of those problems. Now they do look very similar, but they have a few key differences which make everything work much better. So let me just start with the problem of how hard you have to press on this to actually make it work. We are already in Arduino here and we have the serial monitor open. Okay, so you can probably see how much force I have to put on there before it's actually activated. And even when it does work, I have to press really hard for it to get sort of stable. So this was actually a pretty easy fix. If you remember, I was working with two different thicknesses of plastic. And so this sensor is made out of a 3-layer sandwich, all layers made out of the thick stuff. Last time I tried to make the middle separator pieces out of thinner plastic. That didn't work. So the last combination that I've tried, which works, is of course to have a thick middle piece, but then have a softer and more pliable piece of plastic on top. That's exactly what I've done here. This is the box, serves as a base, and then I have two of the thick slices of plastic on the sides here. And then on top of that I have a very, very thin piece of plastic which is very flexible, and so I'm able to activate this with a much softer touch. The second thing that you can probably see at a glance here is that this strip of copper here is very thin on this sensor, whereas all of the copper here is quite wide at both ends. So what's going on there? Well, it turns out that once you have a very functional and sensitive sensor, the amount of pressure that you give to it at a specific spot actually changes the circuit, and so it changes the reading, which means that it's no longer positional. If I press here but press lightly, then I get one value. If I press the same spot but harder, I get a different value. This is mostly caused by the amount of surface area that makes contact between the MiniDV tape and the copper tape. And so by making the electrode much thinner, even if you press harder, you're not really applying that much more surface area. So that was the second problem and the second solution. Now the third one is, I think, the most interesting one, and it has to do with the voltage divider circuit itself. So if you remember, voltage divider, the way it works is that we're basically measuring the difference between the resistance on this here variable resistor setup and then the little resistor that we have in the voltage divider circuit. So that's one bit of information. The other bit of information we discovered last time, and that's that the two sides of this MiniDV tape has different resistance. So the side that looks like it has a metallic sheen to it has a much lower resistance, and I was able to get good readings out of it very easily. But it turns out to be really fragile, so I did break it a couple of times and have to start over. The other side, that's a little bit more matte and plastic looking, has a much higher resistance, and I wasn't able to get good readings out of it last time. But of course, that just has to do with the voltage divider circuit. So if I have a much higher resistance material in my sensor setup, then I also need a much higher value resistor in the voltage divider. And that's why I've swapped the 10K resistor that I was using before out with the 1 mega ohm resistor, which is the highest value that I have. Because like this, I will be able to use the much stronger non-metallicized side of the tape and hopefully make a more sturdy sensor. So that's the third problem and the third solution. And that's how I made this first prototype of the new sensor. So let's quickly see how that works on this original sensor here. As you can see, at this end, we're getting a reading of 1021 or 2 or so. And at this end, 1015, 16. So we're getting a full 5 or 6 points of resolution across this whole length here, so that's obviously no good. Now let's try the new sensor. We'll just clip this on here, like that, quick and easy. Oh, first of all, look how softly I'm pressing here. Oh yes, and we're getting beautiful readings. Let's see, and we're getting 930 or 40 up here, 550 or 60 down here. So we're getting quite a high resolution, which is nice. And here in the middle, of course, 700 or so. So this is exactly the kind of sensor that I'm going to be making today. I am going to use one of these boxes as a base. I'm going to put 2 of these sensors on here, and then I'm going to use that new setup to expand this virus pad that I made a couple of videos back. So we're going to have a setup something like that. That's gonna be awesome. So this also means that I won't need this microcontroller here because I'll be able to just read these 2 new analog sensors off the same microcontroller from in here. So I'll have to open this up, pull some cables out and do some stuff like that. But that should all be good fun. So let's get started. So I'm just gonna grab a fresh box here so that I can use this one for reference. So the first thing that I know I'll need is some plastic for these layers here. So I have some of this very thin plastic here. This comes out of a food container, and this is very soft and pliable plastic. I also need some of the thicker stuff. That should be more than enough. Then I definitely need some double-sided tape, and I need some copper tape. So the first thing that I want to do is lay down this thicker plastic in the form of these side rails that I have here, except of course I need 3 rails. I need 2 on the side, 1 in the middle, so that I can have 2 sensors running down the length of the box. Let's see. So that is the space that I want for the sensors. So now I need to glue down some of the thick stuff here in the outside areas. Okay, so these pieces need to be covered with double-sided tape. Of course, take off the protective covering first. That really is the easiest way to do this. Stick the plastic down onto the tape instead of the other way around. I'm going to cover them fully on the other side as well. Okay, that's the last one. So that was a little bit slow, and also now my scissors here are very sticky. I can clean those up a little bit with some acetone later on. It might be a good idea to put the thin bottom electrode on first for both of these, because that way I can run it under this piece of plastic which is here at the end, or at the other end, as the case may be. You want 0 bumps on this cover here. It has to be perfectly flat. If you get anything stuck underneath it, there's a good chance that you might create a short. So now we're ready to stick down all of the spacer pieces. So that's that centimeter spacing. Very nice. So now I'm ready to lay down the top plastic pieces here, which are the ones that have the MiniDV tape on them. So now then I need to stick the MiniDV tape down onto these pieces of plastic, 1 strip on each. This is a little bit tricky because I'm going to glue it down with the double-sided tape, but I need to make sure that none of this peeks out under the edges of the MiniDV tape, because that would just make the plastic stick to the layer below it. Let's just compare it to the MiniDV tape. See, the MiniDV tape is like almost a millimeter wider, half a millimeter wider maybe. I should be able to line these up perfectly. That's what I need to do. So I'll just stick it down on one of these. Let's see. Okay, that should be good. So that's on there. So I just flip over the plastic and then I can just look through it and see where I have to line up the tape exactly. Okay. That's one. That's the other one. Cool, so now we're almost ready to stick the MiniDV tape to these pieces of plastic here. But first let's just think about something. We need the MiniDV tape to connect at one end permanently to a secondary electrode, which just runs a voltage through it. I want to do that at the opposite end to the bottom electrodes, so down here. And I want to keep in mind that we will be reading on one side of the tape and not the other. That's pretty simple actually. This can be a single electrode for both of these. I'm going to run a piece of copper tape across here, and this is going to be laid down on top of it permanently, making contact right here. And then I'm going to stick some standard transparent tape down on top of it to stabilize. And then I can run that secondary piece of copper into the box to make my connections. There. Something like that. The reason I'm not putting it right up against the sensor area is because I need a little bit of double-sided tape to be free, which will help to stick these plastic pieces here down. So we're getting there. The next step is to get some MiniDV tape onto these. To open up a MiniDV tape, there's a little tab here on one side, which lets you open the lid. And then there's a button down here, at least on this brand, there, and that will allow you to just pull out as much tape as you want. Let's see, one piece like that. Make sure you don't have any double-sided tape sticking off at the ends here. And then you can peel off the backing and stick down the MiniDV tape strip here. You want to get the metallicized side up against the glue. Okay, that's what we're going for now, so that we can use the non-metallic side as a sensor surface. You need to make sure that you perfectly cover all the double-sided tape. Take your time, there's no hurry. If you get it wrong, you'll have to start over. Yes, perfect. Look at that, perfect. Now for the other one. So now that we're using the non-metallic side of the MiniDV tape, it's much less fragile, but you still have to be careful while handling it, especially when you have these double-sided tape and glue and stuff like that, because once you get it stuck on there, there's no getting it off without breaking it. So just be careful and take your time. Yes, once again, very nice fit. Excellent. So almost there. Now I'm ready to peel off the rest of the backing material on here. Let's get rid of that. Ready to stick it down. The most important thing here is that you make sure you get it down straight with the MiniDV tape right in the middle of the sensor section, and that the end of the tape is lying across this secondary electrode here. So that was okay. This end here looks very good. It's lying up across, making connection with the copper. And then I'm ready to stick this down. Okay. This one turned out a little bit weird. It's sort of slanted off to the side. Well, so's the other one. I think it'll be fine. As long as the MiniDV tape makes contact with the bottom electrode, they will be fine. And this contact here, I think, should be as easy as sticking down some normal transparent tape on top, just to keep those two together. So let's get a little strip of tape, just enough to cover the loose bits. Excellent, so now there's no sticky bits left on the top surface, which is very nice. So I am going to connect this to the virus pad and make a full instrument out of it. But first I want to just test if the sensors actually work, if I put together everything correctly. And for that I'll just get back to the same circuit that we used before. We'll clamp down one side over here and the other side to one of these. Careful not to break this. There. Okay, we're back in Arduino, we're plugged in, we are reading the serial monitor. In principle, this should already be working. So, we're on this sensor over here. Let's see. Please, 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 please. Yes! Getting a good clean reading. I don't have to press too hard. 860 is 70. 600 and so. 700 and that. And what about a slide? Oh man, that's excellent. That is excellent. That's working really well. Cool. Let's try the other one. Clip in on the other side. And see, yes, same story, same kind of range of readings. Oh man, that's so good. Okay, so there's no doubt in my mind that that's going to work just great. So let's disconnect from the test circuit and then start building up the extension to the virus pad. So if I'm going to use these sensors as an expansion to the virus pad, then there's a couple of things that I need to figure out first. First of all, this is how I play the virus pad. The knobs are off to one side and the buttons off to another side, and the notes go in this order. And I have direct access to everything. But see, my idea for these sensors is that I want to use one of them as a pitch bend control, and I really want that to be a vertical setup. So that means that this doesn't really fit together. So I'm going to figure out some way to be able to turn the virus pad around and play it like this. So I still have access to the knobs. The switch is a little bit harder, but still reachable. And it would allow me to situate these sensors right next to it on the left. So this will probably mean unplugging all of the sensors on this guy from the multiplexer and then putting them in a new order. I'll figure that out in a second. The other thing I need to think of is the connections themselves. I need to connect each of these sensors through a voltage divider. If you remember, on this one I used a single voltage divider circuit for all 16 sensors, but that's only possible because I read these sensors through a multiplexer, and so I can put the voltage divider before the multiplexer. So I won't be able to do that this time, but I will be able to use this very same circuit that I have right here, and then I'll just quickly put together another one for the second sensor. So I'll need a little bit of strip board, I'll need a 1 mega ohm resistor, and then some male headers here, a triple and a double. So there's our two voltage divider circuits, and now we need some more cables. I'm not going to use these alligator clips here. Here's some more cables. We have a triple cable. These will connect everything to the microcontroller. And then we have 3 more cables here. 2 of them are for these electrodes, and the last one is for the 3-volt rail right here. So to pull these 3 cables here out to the electrodes, I'll need to make some holes in the box. I'll put one down on the side here. And then one next to each of these. That's what those look like. So let's see, I'll get a little bit of solder on each of these electrodes here. And now I can pull the cables through here and solder them to the copper. I want to have the glue gun on standby for this whole operation because the copper tape here is super easy to break, so I'm going to use some hot glue to stabilize the setup as soon as I finish soldering the cable. Get some hot glue on there. I'll put a little drop of hot glue on the inside as well here for the cable. Okay, now the next one. And the final one that goes out to the 3-volt rail. Put it on the inside. Now we can plug these into the voltage dividers and then start putting everything together. So I need to get one of the sensors in the middle plug over here, and then the 3-volt rail on the side header, like that. And then in the other voltage divider I only plug in one cable in the middle rail, and that's not the middle rail. That's the middle rail. So then now what needs to happen is that these 2 sets of triple cables here need to somehow get over to the middle box where the microcontroller is, and I also need to make some kind of base to connect this piece here to the rest of it. Okay, here we go. I'm going to make a common base for all 3 pieces, then I'm going to make 2 layers to raise this up a little bit, and then I'm going to use the same kind of technique as I used here to hold it down. So let's see, let's get some cardboard. There, that's the expanded base. Let's just get a quick glue on there. There, like that. I'm gonna just wait a second before I glue this main part down because I'm still not sure how I'll need to manipulate it. Now we need some of those inner pieces which help to keep everything stuck together. That's one piece, that looks great. Two, we can just use this as a template. There. Just stick those together. I'm just going to stick this down somewhere around the middle. So let's see how that works. Okay. So, okay, let's see. What I feel like now is that the next thing I should be doing is connect this hole here with this box over here. Let's just mark out where that goes. Through here. So. That's the channel that the cables run through. Now I need to make a hole straight down through here. Okay, we don't need to run so many cables through this time as we did last time. So this should be quite big enough. And when we set this down on top, we now have access to that hole. Oh, one thing that I think I'm just going to do really quick is glue down the two voltage dividers inside this box because I don't want them rattling around, touching each other so that the sensors short out each other. Down in the corner there. Not too much glue. I want to be able to take them out if I have to. Okay, I think that's set quite enough. We got our cables. Just push them in through the hole here. And now we can push the new sensor module into place. I think it's time we glue this one down as well. Sweet, and now we can pull the cables through here. Let me just open this up, pull it aside so we can see what we're doing. That's what that looks like inside. And there's the other. Okay. Oh, actually, you know what? Okay, that was really stupid. This is not the box with the microcontroller in it. Damn it. Oh, I've been so stupid. So now, actually, these cables aren't going to be long enough. Okay, I think I'll be able to make it work. I'm going to unglue the voltage dividers from where they are right now. And instead I'm going to glue them down on the cardboard right next to the exit hole. There, so that's very strange looking, but I'm afraid that's what we need to do to make this work right now. Okay, I think that's set. Good enough at least. Let's close this up. Make sure we get all the cables inside there. Okay. And now these cables should be long enough to reach up inside the second box and connect to the microcontroller. At least I hope so. Otherwise I will put on an extension on each cable, but I think it should work. Very careful. There's the hole. So let's open up this one. And as you can see, that's where the microcontroller lives. Now all we need to do is push these two cables up through here. And then we'll plug these into, let's see, 16 and 17. Okay. Very cool. So now, close this back up. And there you go. Now everything is connected. That's very cool looking. So now I'll be able to play like this and activate these sensors like this, even both of them at the same time. They feel really good. So I'm going to test this out first just the way it is, and then I will figure out if I need to change the order of these buttons here, but for now I'll just leave them like they are. So we're basically ready to connect this to the computer now. We'll have to update the original code from the virus pad, and so I'm going to be spending a few hours looking into that, and then do some testing and see how everything works. So let's do it. We're back in Arduino, and here is the first test sketch for the sliders. This is super simple, just reads both of the sliders and prints them to serial. So let's upload that. Very good. Let's open the serial monitor. So yeah, we're getting some low readings. We already know that they work. I just want to make sure that I connected everything properly. So there you go, that's sensor 2. It reads from around 550 and up to 850. There's some noise on these sensors, but I am going to introduce a filter function later on. Sensor 1 from 530 or so up to just under 800. So that works great. And that's all we're going to get out of the first sketch. Let's have a look at the next one. So sketch number 2 is much more complex. Essentially, I've put together the full function that I need to incorporate these sensors in this instrument, but without including the code from the rest of the virus pad. So the idea here is that I'll be able to see the output from both of these sensors in MIDI range, and then it should be easy to transplant that function over to the sketch which runs the virus pad. So this is all pretty standard stuff. For each of the sensors I'm defining a pin and then some variables here. And the minimum and maximum values here are hard-coded in, and that's so that I can map the input on the sensor to a MIDI range output. The threshold value is because when I let go of the sensor, it drops to close to 0. So I need to have a case where I can read values that are lower than the minimum. So I do that for both of the sensors, and that's basically this section here. And then I also keep track of the last input and output values for the exponential filter. So then here we have the functions for the filter, which help me smooth out the readings, and then the main function here. So I read the two sensors separately, keeping track of the previous readings. Then I filter the reading, and then I map it inside MIDI range. And then in the case of sensor number 1, I'm outputting that as a pitch bend signal, but for now I'm just printing it to serial. So slider 2 gets exactly the same treatment for now, but because I will be outputting pitch bend here and a continuous controller down here, I'm just keeping them separately so that I can keep track of differences between those two. Let's try to upload that. Great. So let's see this output here. Excellent. Okay, so the reading here is a little weird. If you have a look at it right down here. The reason why there's some empty spaces in between the readings is because I'm only printing a number if there's a change in the reading from the last reading. And that helps me keep track of whether or not there's a lot of noise on the sensors or not. I'd say the readings are quite stable, and they are indeed mapped more or less between 0 and 127. So that's all of the testing I'm going to do on the sliders. Now is the time to actually apply that code and these sensors to the virus pad itself. So the way I do this is actually pretty interesting. Of course, in this test sketch here, we have a bunch of variables. Now I've made sure not to name any of these variables the same as any variables in the virus pad, and so I'm able to just copy and paste these over onto the other sketch that I was already using for the virus pad. And then comes the main function here. This is called void loop, which is just the standard name that an Arduino sketch starts out with. But if I take this and I change the name of it to something like slider reading function thingy, then I can just take this whole thing, copy it, and paste it over into the new sketch, or should I say the old virus pad sketch. And then I can call that function from within the main function in the main code, and I'll only have to adjust a few of these things to make it work inside the larger context of the virus pad. So of course I've already put together that sketch. Let's have a look at it. And here we have the complete virus pad code, including the new sliders. So this whole section here I'm leaving exactly the same, and then I've input the section with the slider values here separately, marking it with a little comment so that it's easy to find. And then it's all the same, all the same, all the same. We run through the void loop, and that's all the same all the way to the very end. And then at the very end, I insert this function here. So then I call a function that's called read sliders. And lo and behold, right down here is the slider reading function. It's called read sliders. And so every time the main loop comes to this part here, it will run through this function, which is basically the function that we had before in the previous sketch, except that this time I've swapped out the serial prints for USB MIDI outputs. So let's try and upload that. Okay. So of course this output is pretty boring. It's just what we've been looking at this whole time in the virus pad, because I commented out the serial output in the slider functions. So in order to know what this here new part of the code actually does, we're gonna have to open up the software synthesizer, hook everything up and see what we can get. Oh, actually, before I do that, remember how I told you that I was going to change the order of the buttons? Well, I did that so that now I can turn the instrument this way and the buttons are in the same order as before. The way I did this was literally just to plug each cable out of its old position into its new position and so on for all 15 cables. So the way I figured out how to do this was also pretty simple. Here's a little schematic that I made. So this of course corresponds to the buttons in the old position, 0, 1, 2, 3, 4, 5, 6, 7, and you can see the division here, which is the larger space. So then the number 0, 1, 2, 3 corresponds to this direction. So now to figure out where the new numbers are going, we just basically turn these around the way that we want to finally turn them, and we start to number them here. I'm numbering them in the corner, so it's 0, 1, 2, 3, 4, 5. And then you end up with a grid here where each square has two numbers, the number that you need to take a cable from and the number where you need to plug that cable in afterwards. And that's pretty simple, straightforward, and it worked out great, as you will see in a second. Okay, so let's open up the synthesizer and see if we can make some noise. Okay, so here we are in Yoshimi, and I've already prepared everything. As you can see, we're connected through jack. And in Yoshimi, it's very easy to save your state. So I've just loaded my virus pad state, and that includes, let's see, 2 channels here, one with a drum kit on it and one with the synthesizer on it. Then we have 3 different effects down here, which correspond to the potentiometers and one of the sliders. Awesome, so that works. I hope you can see that little knob turning down there. And I've learned these through the MIDI learn function within Yoshimi, but then I've saved them with the state, so now they've become permanent with this instrument. The second slider here, of course, is supposed to control the pitch bend function, but I don't have any display for that inside the Yoshimi interface, so we'll hear that in action in a second. For now, I'm going to turn off these 2 potentiometer effects, which are a reverb and a chorus, and I'm going to focus on the phaser effect here, so I can turn that up and down with my slider. So I can see that right now I'm in the synthesizer mode. That would be the drum mode. This is the synthesizer mode, so let's try to play a note. That still works great. That works great, so I guess I got the order of the keys correctly. Polyphonic still works just fine, no problem. And so let's see if the pitch bend works. Oh yeah, that definitely works. So I've included the functionality of whenever you let go of it, it automatically sends back a pitch bend of 0 or 64 actually, like a medium pitch bend with no change to the note. But yeah, it definitely works. So let's have a look at the other function. That was a phaser. And notice here that I've applied the result of this slider both to this knob down here, which controls the volume of the effect, but also to the frequency of the effect. So you get a pretty intense effect from the slider. Let's see how it sounds. So some of the effects in Yoshimi are a little bit annoying in that they really only start working from about halfway up the MIDI signal. So that's what's happening here, in that the first half of the slider gives 0 result. So I will go back to the code and do a different mapping so that I can better use the full range of the effect. So let's have a look at the drum mode. Okay, so maybe a pitch bend isn't so interesting here, but maybe it is. Check it out. That is definitely interesting. How about the other ones here? Drums that have a longer decay, of course, it works better because you can hear the effect for longer. Oh yeah, that's also pretty interesting. Let's see. That's crazy. Yeah, the phaser is maybe not so interesting for the drums. Although that is pretty cool. So that appears to be fully functional and also pretty sturdy. I've been pressing on it and playing around with it for a while. I haven't broken anything, so I'm really happy with that. I'm gonna mess around with this for a few hours and try out some different instruments and filters and stuff so that I can record a little bit of music to put at the beginning and the end of the video. So I'll catch you after that. Wow, what a build. I have to say I'm extremely happy with how that turned out. The virus pad is looking more and more awesome, and the sliders turned out to be an excellent addition to the functionality that was already in place. I love the modular style that it's taking on now. So I don't know what's next in the program. It could be yet another set of DIY sensors to make yet another expansion for the virus pad, but I'm not really sure yet. So you'll have to wait for the next video to find out. If you want to make sure that you don't miss any of that, then you should definitely subscribe right here in the Kontinuum Lab YouTube channel. Turn on notifications and also find me over on Instagram, also as Kontinuum Lab. And that's all for today. Take care until next time, and I'll see you in the Kontinuum.